Hello everyone, I'm Golden Ashley. I'm here to present the graphics processing units in computer architecture and organization. On completion of this video, students will be able to explain what is GPU and how it is works. Graphics processing unit. So GPU is designed to lessen the work of the GPU and produce faster video and graphics. So GPU can be thought as an extension of CPU with thousands of cores. A GPU is extensively used in the PC on a video card or motherboard, mobile phones, display adapters, workstations, and game consoles. They are mainly used for offloading computation intensive applications. So, this is also known as a visual processing unit VPU. Then a graphical processing unit is a single chip processor primarily used to manage and boost the performance of video and graphics. It is a dedicated parallel processor for accelerating graphical and deeper computations. Okay, next CPU versus GPU architecture. Then first of all we need to know the difference between CPU and GPU. In a GPU they facilitate highly parallel operation and it also has more number of cores in thousands. Then they also need special faster interfaces to facilitate faster data transfer. They have a deeper pipelines. In compared to the CPU, this support serial execution of programs and this also has a less number of cores and no such special interface are required. They have a comparatively shallows. Then what are the GPU features? So actually here 2D or 3D graphics we can maintain, then digital output to flat panel display monitors, then textures mapping, application support for high intensity graphics software such as AutoCAD, then rendering polygons, support for color space, YUV color space and hardware overlays. The development of GPU. The first GPU was developed by NVIDIA in 1999 and needed as GeForce 256. This GPU model could process 10 million polygons per second and had more than 22 million transistors. This is a single chip processor with integrated transform, drawing and bit BLC support, lighting effect, triangle set of clipping and rendering engines. Then the GPU is connected to the CPU and is completely separated from the motherboard. The RAM is connected through the accelerated graphic port AGP or the PCI Express bus. Sometimes GPU are integrated into the north bridge on the motherboard and use the main memory as a digital storage area. But these GPU are slower and have a poorer performance. Then the accelerator memory in GPU is used for mapping vertices and can also support programmable shade implementing textures. So mathematically vertices and accurate color formats. Then applications such as computer-aided design can process over 200 million operations per second and deliver up to 17 million polygons per second. So the main configuration of the CPU process or graphics coprocessor, which is independent of GPU, and graphics accelerator that is based on command from the GPU. So the GPU pipelines are shown in the figure. Then the input assembler storage. This stage is the communication bridge between the CPU and GPU. It receives commands from the CPU and also pulls geometry information from the system memory. It output of a stream of vertices in an object space with all their associated information. Then vertex processing. This process vertices performing operations like transformation, skinning and lighting. So a vertex shade takes a single input vertex and produces a single output vertex. Then pixel processing. Each pixel provides by triangle setup is fed into pixel processing as a set of attributes which are used to compute a final color for this pixel. Then the computations taking place here include texture mapping and math operations. So then output merger stage. So output merger stage combines various types of output data to generate the final pipeline result. Thank you. Thanks for listening.